All right. So, hello and welcome to the Volume Populators weekly meeting for the Kubernetes storage SIG. This is a weekly meeting that we've been having for going into detail on volume populators. This is the fourth meeting, and we've covered a lot of material, I think, in our first three meetings and made a lot of useful decisions. And I don't have any agenda items for today other than sort of review and answering questions for those who have missed the original meetings and just want to understand what the idea is. So who here is new that hasn't been to one of these prior meetings?
Absolutely new. This is my first time.
You're new? Okay. Anyone else? Is this the first meeting?
Ben, I think this might be the first time that I'm attending this meeting as well. This is John
Okay.
Terpstra.
Welcome, John. Yeah. So John, I know that you attend the data protection working group meetings, and I have covered some of the volume populator stuff in those meetings, like half a year ago. Early on, I was sort of showing what I was working on. So this is a continuation of that work.
Okay.
I guess before I launch into the review, are there any specific questions or any areas where people want me to focus on? Nothing specific. Xing, you seem to have a something in mind that you wanted me to cover. So, where did you want me to focus? Just the motivation?
Just like explain like what's the if we don't have this currently, what does a backup vendor has to do?
Okay.
If we have this, like what's the benefit? I mean, for me, I think the one thing that I found very important for this one is the placement part. I mean, the wait for first consumer one.
Sure.
I don't think that's possible without this feature.
Well, yeah. So I'll talk about the motivation and how I arrived at the idea and what the alternatives that I did consider were, because I think the alternatives are the what will answer your question when we think about other ways to accomplish this and how we got here. Okay, so yeah, the people have been talking about data populators for various purposes for even before I got involved in this feature area. There are various potential applications for data populators, but the way that I got interested in it was from thinking about doing backup and restore. I actually, I guess it was about a year ago now, devised a whole prototype API design and implementation for Kubernetes backup and restore, where I invented my own CRDs for backups and my own controllers, and I started making changes to the CSI RPCs and modifying CSI plugins to implement them. And as all the pieces were coming together, the place where I got stuck was when you were trying to take a backup and turn it back into a PVC, when you're basically doing that restore. I realized that to implement what I wanted, we would need to change the core Kubernetes API, because there's an emission controller in Kubernetes that validates PVC data sources, and if they're not either another PVC because you're doing a volume clone or a snapshot because you're restoring a snapshot, the emission controller just drops the data source field entirely and makes it blank if you put something other than those two things in there. So I started thinking, well, okay, what I'm going to have to do is propose the whole backup design, get everyone to agree that like this is the right design, and then I'm going to have to go to the Kubernetes API SIG and SIG API and ask them to say, can backups be a new feature gate, right? And I started thinking, well, this is kind of nasty because we have two already. I'm going to be proposing a third. I know that there's other people that want to do other things with regard to, populating volumes with, basically creating a volume that's not empty, a volume that has something in it, where that something could be a variety of things. And so so I started thinking, well, is there a way that we could address all of these problems all at once? And so the proposal I came forward with back in 118 was the any volume data source feature gate, which basically said, okay, instead of having a different feature gate for every type of object that could be the data source of a PVC, let's just add one that's like a wild card. So like if you enable this feature gate, anything can be the source of a PVC, and then we won't have to bug the SIG API guys anymore when you want to add new data sources. The problem with that is, of course, there's all kinds of objects that are not going to be valid data sources for volumes, right? I mean, there's a million CRDs out there that people have created for different purposes, and nearly all of them don't make sense to be the source of a volume. So we needed a way to determine which things are valid and which things aren't valid, and then if they aren't valid, to provide feedback to the end user like you would get normally if you do something that's not going to work, so that so you don't sit around waiting, because in Kubernetes, sometimes things take a long time to work, but like you don't really know if they're going to fail or if they're going to eventually succeed, and so you expect to get some sort of event that tells you what the current status is. So I started working on a way to provide feedback to users about, is their PVC going to bind or is it not going to bind? And I'll go into in more detail about exactly how that works in a minute. But with regard to the motivation, I mean, does that make sense to everyone? That we could have just said, you know what, we're going to implement backup and restore. We're going to create a backup CRD. We're going to add it to the official list of supported data sources with its own feature gate, and then gone off and said, this is how we're going to do backup and restore, where like that was just one additional specific CRD that you're allowed to restore from. And is it clear why that's not a great way to do this? You guys might all be on mute, because I don't know if this is making sense or not.
Yeah, it makes sense.
Okay.
Otherwise, it will get crowded, right? If you keep on increasing the feature.
So Xing, you follow this part of it, right? That we don't want to have to go back to SIG API every time we want to add a new data source. We want to have like a generic way of handling this.
Yeah.
Right. Okay. Okay. So that was that was on the API side and the sort of the user interface side. We need a way to allow other things to be data sources, but to still provide feedback to end users when the it doesn't look like the thing that they provided is valid. And so just a really brief recap of how that's supposed to work. We looked at doing a validating webhook that would reject data sources that didn't match a specific list of registered data source CRDs. But we didn't like that because it would change the behavior such that if you created a PVC with a data source that pointed to something that wasn't registered yet, it would be kicked out entirely. And so the actual plan is to implement a controller that will simply post events to those PVCs if the data source of the PVC is of a kind that doesn't appear to be a registered valid data source. And we're going to have a new CRD called volume populator, which will be how you register these valid data sources. So then all that leaves then is the implementation side. So now assuming that all this goes through, and we have a way to, well, actually the feature gate's already in. So if you use the feature gate, you can invent a new CRD called volume backup, if you will, and you can implement and you could, well, you could implement the way that you restore from backups in a variety of ways, but Kubernetes won't stand in your way, right? You'll be able to create a PVC with the data source, and any controller then will be able to react to that and create the appropriate PV that has your restored backup. So the two approaches then for actually populating the volume would be, one, we could, right now, the only way that you get dynamically provisioned volumes is with the external provisioner sidecar. Any new volume request goes to the external provisioner sidecar, and it looks at the data source and it says, okay, if it's empty, I'm going to ask the CSI plugin to create me an empty volume. If it says there's a snapshot, I'm going to ask the CSI driver to restore the snapshot. And if it's a volume, I'm going to ask the CSI driver to clone it. And if it's anything else, just going to ignore it. Well, if you imagine that we had invented some backup feature, you could just have another else if down at the bottom of that check inside external provisioner that says, if it's a backup, then ask the CSI driver to restore the backup using some new CSI RPCs that haven't been invented yet, right? That would be one way to do it. And just to say, you know what, this is another CSI problem. All of the work of restoring backups is going to be the responsibility of the CSI driver, just like restoring snapshots, and that's it. We could do that. Like that is a choice that we still could make today if we wanted to, but I really don't want to do it that way. I would like to have another way of restoring backups that doesn't rely on every CSI driver understanding how to do the restoration. So, and this part of the design overlaps with some of the other use cases for data populators that we're aware of. So just real quick, one of the other well-known use cases is like, if I'm running some sort of a virtualization engine on top of Kubernetes, like KubeVirt, for example, and I have an image repository for my VM images, and I'm trying to create a PVC that's going to represent like the boot volume for a VM. I'd really like to be able to get that VM image from my image repository into the PVC so that I can then boot up a VM from it. Like that's another potential use case for data populators that shouldn't have anything driver specific in it, right? It's just, I have a bunch of data. I need an empty volume. I need to put the data into the volume in a reliable way so that I can use it for like a virtualization use case. Lots of backup implementations could be done in a similar way, where all you need is to create an empty volume of the appropriate size, and then some controller will fill that volume up with the data. So the challenge is how we manage that workflow. So if we just allow the user to create a PVC that has a data source of something that is not a snapshot, not a PVC, so the external provisioner sidecar doesn't understand it, but it's like either a backup or an image or something. And if the behavior is that like the external provisioner sidecar sees that request and it goes ahead and creates an empty volume and binds it, such that such that you could come along and take that empty volume and then fill it up with the data later. The problem that causes is the moment that the PVC becomes bound, if the user who had created the PVC had any pods attached to it, like those pods will be ready to run and they'll start running immediately. But you haven't actually put the data in there yet. And so we looked at this, I don't know, a year or two ago. I don't know how long it's been, Sheng. Like how can we like get the empty volume, but not let anything attach to it until it's been populated? And we've seen various proposals, all of which involve changes to the Kubernetes API or trying to hack the user's workload. So yeah, let me sort of outline the alternatives that I'm not in favor of first. But one alternative was like just to add a new field to the PVC that was like not ready to bind or like not ready for use, so that like you could have a PVC that was created and empty but like still being populated, and this would be a signal to kubelet that would say like don't use the volume yet. And then the idea would be that the populator would do its population first and then flip that flag and then allow things to proceed. So the problems with that approach are, one, like you have to change kubelet and you have to change the Kubernetes API to do that. And two, like it's not clear like how you would, if you're just using an ordinary Kubernetes pod to do the data population, like how do you tell Kubernetes like this is the populator pod that is allowed to attach to the volume and this is the user's pod that's not allowed to attach to the volume? It becomes very weird. And we also discussed a potential implementation that was like based on taints and tolerations, which is a node thing. We could do something similar with PVCs, but again, that would be like a Kubernetes API change. There's a lot of complexity around like, well, it shares some features with node taints and tolerations, but in other ways it doesn't. And so like, it's not clear if we should reuse the name or use a different name. And it's not clear how much it overlaps with those taints and tolerations. And so like, we had a lot of open questions around that approach. And so other approaches that at least I've
Hey
rejected.
Ben, can you please re-explain why we cannot put the field? You mentioned something I didn't clearly understand.
Okay, so there was a proposal to add the concept of a volume taint and a volume taint to PVCs and a volume taint toleration to pods. Like these would be new API fields that don't exist today, and they would have similar semantics to node taints and node tolerations. But we decided not to pursue that approach because like that would be changing the Kubernetes API. Like this would be entirely new fields that don't exist, and it's always more work to change the Kubernetes API. You have to have very good reasons for doing it, and it was going to be confusing because the names were similar to existing concepts, but the actual implementation would have differed in subtle ways. And so we were working on like trying to figure out those subtle differences, and then we kind of decided that it was very hard, and we didn't want to, nobody wanted to carry that implementation forward, basically. Not that we can't still do it. I mean, if somebody says, you know what, I want to implement volume taints and tolerations, the field is still open to do that. It would be okay, but I would warn anyone trying to do that it's not going to be a small effort, and that there's some issues around the details that haven't been hashed out yet. So does that answer the question?
Yes.
Okay.
Yes, thank you.
Okay, the other approach that we rejected was some sort of scheme where you don't modify the Kubernetes API, but you instead like try to stick init containers into the pod, so that like before the pod can attach to the volume, like there's another init container that actually does the data population work. And in very simple use cases, this would be a workable scheme, because if you only ever have one pod connected to a volume, and you can reliably inject an init container into that pod that would do the data population, you could have a workable scheme. The problem that I see with that approach is, one, you're mucking with end user objects, right? End user created a pod. He might have his own init containers, and here we are like adding another init container that he's not expecting to see. It creates a strange user experience when we're injecting init containers into customers' pods that they don't that they didn't expect. But even worse, like there are use cases where you have like multiple pods that are all trying to share a volume, and it's not clear like which pod would need the init container to do the population. Or additionally, there's use cases where you create the PVC, but then you like don't attach any pods to it, and you just try to clone it or take a snapshot of it. And it's like, before, if you're relying on init containers, then there's no data until the first pod runs. And so if you take a snapshot or you clone the volume before any pods have run, you're going to get an empty volume. So there's a lot of downsides to trying to do this through init containers. So the approach that I came up with, that I've been advocating for, and that I have prototypes of, is just to create a second PVC. So basically, we'll have a generalized workflow where if somebody creates a PVC with a data source, And that data and the population of that data source is not handled by like the external provisioner sidecar itself. And some maybe, but like for the sake of this discussion, let's assume we're dealing with one that is generic and it's not done by the CSI driver. What you'll do is you'll have a populator controller that'll be watching for PVCs exactly like the external provisioner. When it sees one that it has a data source that is responsible for it, what it will do is it will create a second PVC that looks exactly like the first PVC, except it has no data source. And it will wait for that one to bind, because that will create an empty PVC that is otherwise identical to the PVC that the user actually wanted. But because you've created a second PVC that the user doesn't know about, they don't see this happening. It's happening sort of in the background or in another namespace. So then after this empty PVC is created, what I call PVC prime in most of my examples, you can create a populator pod, an ordinary pod that's in this sort of hidden namespace that the user doesn't know about, that can just bind to the PVC and do whatever work it needs to do to populate the volume. There's no API magic required. This is just an ordinary empty PVC, an ordinary pod in a sort of admin controlled namespace, and the pod does whatever it needs to do to populate the volume. It could just attach to it and write data the normal way. It could, using special information, talk directly to some storage controller and make some magic happen. It doesn't matter what this pod does, but there's just a pod running that has an ordinary volume attachment to the PVC, and it runs until completion. And you could do all the things that you would normally do here, like where if the pod gets killed before it's done, you can restart it and resume the operation. You can handle nodes going down and nodes coming up, and the pod moves to another node and it continues populating. Eventually, the pod finishes whatever work it needed to do to set the volume up with the data that the user had requested. And once we reach that point, then what the trick is basically to rebind the PV that got created back to the old PVC that the user asked for. And in most cases, like this could happen very, very fast, right? If population is an operation that's implemented so in some optimized way, like the user could create the original PVC, the controller could see it and immediately create PVC prime. The CSI controller could immediately create the PV for PVC prime that's empty. The pod could get started up, within under a second, do its population work fairly rapidly, shut down, signal success. The controller could then see that the pod ran to completion, know that that PV contains the correct data, and rebind it back to the original PVC. And then from the end user's perspective, like it looks like an ordinary volume provisioning operation, right? Like they created a PVC, they waited a little bit, a PV appeared, and a PV bound to their PVC, and they're done, right? No Kubernetes API changes are required for this approach. It just works. And then, because you're rebinding the PV, you do end up with like the PVC prime it ends up in a lost state because it had a PV and then it lost its PV because we rebound it. And then so you have to clean up that PVC prime. You have to clean up the populator pod, but like that's part of what the populator controller does. It cleans up the temporary objects that got created. But all of the magic comes from the fact that you can rebind a PV from one PVC to another PVC fairly reliably. So and that's what I prototyped. So there is a Hello Populator out there. I've provided links to it in earlier meetings if you want to go look at it, that basically does this, or does a flavor of this. I probably need to update it to do exactly what I described, but it basically follows this workflow. And so the remaining work is to to basically find a way to take the common pieces of that populator logic, which is like watching for PVCs, noticing when a PVC gets created that matches the data source that the populator is responsible for, creating PVC prime, attaching a populator pod to it, waiting for the pod to run to completion, and then rebinding the PV back to the original PVC, and then cleaning up the populator pod and PVC prime. All of that is sort of reusable logic that should be the same for any populator. The only piece that is going to be specific is like, what does that pod do? And additionally, the information in the actual CR, which is the data source, needs to get communicated to the pod somehow. So we need a mechanism for like registering a CRD that is a data source, taking all the data that's in it and sort of communicating it to the populator pod, and then waiting for it to complete. And if we can sort of wrap that up into like a reusable library, we could start having all kinds of data populators. But most importantly, and most dear to my heart, is restoring backups. So I like the idea of like having a backup restorer populator that knows how to take backup CRDs and basically put them into a volume using this mechanism. So from the user's perspective, it's no different than cloning from a snapshot. They just clone from a backup, and instead of the external provisioner sidecar doing the work, this other thing does the work, but like they can't tell the difference. They just create the PVC and out pops, you know, a volume with their data. The only other thing that sort of has caused a little bit of complications, and we've discussed them at length in the last week, was this whole scheme of creating a second pod and a second PVC has implications for stuff like wait for first consumer, because normally what happens with like an empty PVC, if you have wait for first consumer set to true, like the provisioner doesn't actually do any work until there is a pod that has been scheduled and attached to that volume. So what we didn't want to have happen was for this thing to go ahead and like just start creating PVCs on like in the wrong location if there was a pod that had wait for first consumer set to true. So this populator pod will have to, or this populator controller will have to sort of match the same semantics, where if a PVC comes in with wait for first consumer set to true, it will have to create PVC prime also with wait for first consumer set to true. And it can't create the populator pod until the original volume has a pod that is on a node. So it would have to sort of, wait until there is a pod that has been scheduled for the original PVC in order to create a populator pod on the same node, so that the PVC prime gets scheduled to the right place, the resulting PV gets created in the right place if there's topology and it matters. And then when we rebind that PV back to the original PVC, it looks like all the rules have been respected, and the topology matches what the user asked for.
I have a question that maybe another question. So let's just start with one. So the PVC type, this can be block and file system, right?
Mm-hmm.
Does the volume populator have to kind of somehow match with that, isn't it?
Yes. So the PVC prime will match all of the features of the original PVC, including the storage class, the volume type, the volume access modes, like all of those things will have to be copy and pasted. So yes, if it is a file system volume, the populator pod will have to attach to it as a file system volume. Similarly, if it is a raw block volume, the populator pod will have to attach to it as a raw block volume. That'll just have to be, an if-then statement inside the populator logic that creates the populator pod to basically say, is it a raw block volume that needs a volume mount? I'm sorry, is it a file system volume that needs a volume mount, or is it a raw block volume that needs a device path? And then that information will also have to be communicated into the populator pod somehow. So like the part of this that hasn't been designed yet is what is the interface between the sort of this generic logic that is going to be reusable for all the populators and the specific populator implementation that like creates this pod that does the population work, because a bunch of information has to get communicated, like, you know, is it a file system volume, is it a raw block volume, you know, and potentially other details. So it's like that part I haven't figured out yet, but like it's pretty easy to make like a, you know, a non-generalized prototype that can handle a specific CRD. And then the trick is going to be, how do we generalize it to support any CRD in any data, any populator type, so that we pass down enough information that it can know what it's dealing with and know how to populate it. I mean, I imagine well, I don't know, like for backups, you certainly want to be able to back up both raw block volumes and file system volumes, right? So inevitably, when we do have a backup design, we're going to have to handle both of those. But it shouldn't be difficult to imagine how to write like a populator pod that can handle both of those cases. It just has to know which case it's in and then do its thing. So any other questions? Xing, did I answer your question? Because I know that it's been confusing around it.
I'm fine. I'm mainly trying to introduce this feature to others in the data protection working group. Yeah, I see the value of this feature. Just want to
okay, yeah.
Others know.
So the remaining challenge is like designing the sort of where do we draw the line between the reusable populator code and the specific implementation of a populator? What does that interface look like? We had talked in the previous meeting about like, do we want to go with like a full sidecar design that with a gRPC interface between, you know, the populator sidecar and the actual implementation? Because like that implies like designing a whole gRPC interface for this thing that would be fairly heavyweight. I was hoping that we could get away with just like a library that you can import, but this stuff is all still TBD, like the exact implementation of the reusable part and what the interface between that and the rest of the code and the populator specific code looks like. And it's not going to be a small amount of code, I think, because it ends up having to copy a lot of the behavior of what external provisioner does. And the only other thing I'll mention that we've sort of covered, since this is a quick review, is I do like the idea of cooperating populator implementation. So just because you define like some data type, which or some CRD, which can be the source of a PVC, doesn't mean that like all of the data population for that type needs to be done by a single controller. I like the idea of being able to split the work between potentially multiple controllers by allowing them to examine fields in the CR and say, okay, this one I'm going to let the external provisioner handle, and this one I'm going to let the generic populator handle, through some policy that is specific to that data type. And the example I use there is like, for some types of backups, we may want to allow the CSI driver to do an optimized thing, and we may want external provisioner to support additional CRDs other than volumes and snapshots in the future. But we may want to do that in a way that it only handles some instances of those CRDs and not all instances of those CRDs, perhaps by like having a format argument that specifies the format of the backup. And so a CSI plugin could say, I understand this format and that format, but not no other formats. And then the external provisioner could only pass down requests for supported formats, leave other ones unhandled, and then some other controller can be responsible for backstopping restoration of formats that the CSI plugin doesn't understand, potentially. That's just sort of like a brainstorm kind of idea, because I don't want to end up in a situation where, like, for any given data source, it has to either always be a generic populator or always be done through CSI, because I think that's too rigid. I think that there can be data sources where you can have a generic populator that knows how to handle it, but if a CSI plugin has a better way to do it, like we should be able to enable that. So this scheme, I guess I just want to point out, this scheme would allow that kind of cooperation so that you could have generic implementations and optimized implementations, and they could work in tandem with each other. If we ever get that far. So that's, I think, basically a review of just about everything without, going into the depth in terms of the code. I don't have like the diagrams that show the.
How far is this down the track, Ben?
Well, yeah, that's a good question. Like I said, the feature gate was alpha in 1.18 and remains so. We can't get it to beta until we sort of solve the rest of these problems, but the feature gate has been merged and is available, so you can at least prototype these kinds of things without having to change Kubernetes. You just have to turn the feature gate on, create your own CRDs, and as long as the feature gate is on, you can use those CRDs as the data source of a PVC, and then install all the other controllers and make them do whatever you want to do. So that piece is in. There was a prototype populator out there called Hello Populator. I've shared the link with that before, the link to that before. So you're welcome to look at actual code that plays this game of creating PVC prime and creating a populator pod, waiting for the populator pod to run to completion, and then rebinding the PVC, or rebinding the PV to the old PVC. That code is available sort of as just a prototype. It's called Hello Populator. There's also a prototype of, well, the proposal for a volume populator CRD, which is how you register other CRDs that can be data sources. That prototype is in the external provisioner repo as a PR. That is still proposed as a validating webhook, and we've already decided we don't like the idea of doing a validating webhook. So I need to rewrite that proposal, and that's probably the next thing on my list to do is rewrite that PR to turn it into a controller that just posts events, and then I'm going to go back and take the Hello Populator and start to reconstruct it and split it apart along the lines I described, so that it could become reusable. But there's nothing to stop you from just like grabbing it and cloning it and experimenting with it today. It doesn't support any of the wait for first consumer, by the way. That was the other sort of new thing that we realized after I wrote the original version of this, is that special logic is needed for wait for first consumer. But aside from the logic for wait for first consumer, I don't think there's any other special cases that need to be handled in that populator code. It's just teasing apart the generic code from the specific code, and creating some sort of an interface that we can sort of support over the long run. And maybe even turn it into like a proper sidecar style interface someday. It seems more ambitious, but yeah. So there's code out there, and I am working on fleshing out the remaining pieces. And I haven't been able to put as much time into it in the last month as I would have liked, because I've been sidetracked with other things. But I'm committed to seeing this through to to beta. Getting all the various controller pieces in, getting the feature gate promoted, and seeing a reusable, workable scheme for all of this. The other, let's mention one more thing. The KEP, there was a KEP that is merged, and I have an updated proposal to the KEP that has not merged for 120. I need to rewrite the KEP as well, but they have asked us to add like metrics for this feature. That's a new thing that I guess they're pushing hard across all of Kubernetes, is like everything should have metrics. We need to sit down and think about what kind of metrics make sense in the case of a data populator. And there's some obvious answers there, like how many volumes have been created for each data source type. Have any populations failed? Maybe even measurement for population time, like how long does it taking to populate volumes? The kind of metrics that could tell an ops person if a particular populator was sort of healthy or not. I think that's what they're looking for. And I haven't spent a terrible amount of time thinking about metrics, but that's something that sort of needs to be done before beta, I think.
May I suggest that in the meeting log, we record the related keps? And perhaps...
yeah. Well, there's only one kep, so it's merged, and I have an update to that kep that is, to move it from alpha to beta, and it's just that kep. There's stuff that's TBD in there, but yeah, I can provide a link to that PR or the original kep and the PR to the kep.
That would be good.
Like. Okay.
And do we have any use case documentation, any examples?
There are use cases in the kep. That's
Okay,
part of the kep.
good.
That I only have 2 use cases listed. One is the backup restore use case. The other one is the, image for VM images for virtualization use case. But like it's not hard to imagine other ones. And so if you want to help me sort of come up with some good ones for the kep, I'd be happy to add like the 3rd or 4th or 5th one to really illustrate the kinds of things that we can do here.
I'll gladly have a look at that. However, I think there's some other people in Dell that I'd like to bring in on this who may have a more intense interest in this. So,
okay.
Yeah.
Interested because of backup and restore, or interested for other reasons?
Backup and restore, data protection. There is a team that has already expressed challenges with restoring a volume backup and then bringing that back into a different namespace. I don't remember the details of the challenges that they had.
Well, yeah, so
that's a different one though. We do have another
moving across namespaces is another very interesting problem that
there was another
need a solution to.
Namespace transfer actually. Yeah, so not this one. There was another one.
Yeah. Well, Xing, do you know how that's going?
I know that the guy, I think it's Mike, who's working on that, he updated that cap. That's what I know.
Okay.
But it didn't merge for 120, so there's no change.
No, it's still in design. I don't think, yeah.
Okay, because yes, being able to move various things across namespaces has been a problem. Moving volumes across namespaces, snapshots across namespaces, or assuming we had a backup, it would suffer from the same problem. You need a way to move backups across namespaces, or you would need some administrator level guy, manually copying them across namespaces. So yes, it's a problem that lots of people are encountering, and we need a better answer, I think. But I am not tackling any of those problems in this working group or with this.
I think initially those two are one actually, and then kind of divided into 2. This one and the other one.
Okay.
In the very, very beginning, long time back, I remember they're actually one.
Right.
Well, I mean, it's a fundamentally different problem, right? Like just moving a volume to another namespace has utility by itself, and similarly, moving a snapshot to another namespace has utility.
Well, you can do it actually today. I mean, it's not that direct, but you can do it.
Well, an admin can do it.
Yeah.
But like, the question is, like, should there be a way for anyone who's not an admin to do it? Mm-hmm. And what does that look like? So,
Yes, I have sorry, my connection will kick me out earlier when you are answering my question, so I have to listen to it on the tape. On the YouTube with recording. But my second question related to the direction of the data flow, right? So from what I heard so far, it seems like when we have an empty PVC, and then the volume populator will pump data to that PVC. That is for the backup scenario, and the other way around would be that the existing PVC already there, and they want to reformat the reverse direction from the instead of just the volume populator, we want to able to read using the same mechanism to read the reverse direction. It is related to that, or we have to have another, volume populator type.
Are you talking about like a revert of an existing PV?
It was like this one is seemed to me fit with my restore story, right? When we want to restore a new PVC, I read from my backup and pump data to that PVC.
To a new
And
PVC,
and for the backup data path, we want the reverse direction, right? We want to read from the PVC.
So in the case of backup restore, like the question of how you get from a PVC to a backup, that is entirely out of scope for this work because there's no need to change any Kubernetes APIs or invent any things to do that. I'm leaving those kinds of questions for the data protection working group to figure out, like how do you take a volume and get it into a backup? Because there's 1,000 solutions to that problem.
So and there's also a backup API proposal. There's also a avoiding backup proposal that is I think someone's working on it. So we'll see if that comes up.
There's lots of ways to skin that cat, and I want to make it clear that like that's out of scope for this. This is really about just only the restore path because it happens to overlap with a bunch of other, how do I create a volume from something kind of problems. But how do I go from a volume to a backup? I have specific thoughts on that, but it's not related to data populators.
Yeah, because in my mind was the component that do that in our product do both directions. Yeah, it read from it or it write to it. It have two directions and they have the logic, similar logic. It just come the different direction. So I kind of wonder if you have the same, but it looks like your volume the populator, which is the other way around, which is similar to like the restore data path.
Yes. We're talking about the restore path and not the backup path.
Yeah, thank you.
In this area. The only other thing I'll mention, because I don't know if this is part of your question or if I just misheard it, but about like a revert kind of a workflow. We don't support reverts anywhere in Kubernetes. You can't revert to a snapshot today. I'm not proposing that populators help you with like reverting to backups either. Like the workflow is always, if you want to basically restore your data.
What I meant by the revert is the reverse direction of the data flow.
Yes,
I think I just misheard you.
Then it's talking about restore, right?
Yeah. So when you do a restore, the assumption, at least in this design, is what you wanted was a whole new volume. If what you wanted was to take your existing volume and have it sort of go back in time to the point of a backup or a snapshot, we don't have solutions for those use cases. As far as I know, Shing, nobody is working on that, or is somebody working on?
I think Alexis is working on something for holding backup API.
As a way to like revert a volume in place.
Oh, not revert. No, I don't think anyone is working on revert.
Okay, I didn't think so, and
that's fine with me. I think that's not what Fang is asking either. So yeah, that one was like someone raised that some time ago, but we don't have a strong use case for that. So yeah, that will be like a new feature. If
a lot of people talk about I'd like to revert to my backup or I'd like to revert to my snapshot, but like no one ever has a compelling reason for why that's better than just creating a whole new volume. So I think we've decided not to address that problem in either this area or in the data protection working group for the time being.
Yeah, and also I think that's probably not a typical backup restore use case anyway. Revert, it's not usually used in backup restore, to my knowledge.
Well, it tends to come up.
Yeah. I mean, you can, it's like a convenient way, right? At least traditional way. But I mean, backup vendors normally don't depend on that one because they restore it to they back it up to a different place. You can't really use that data to do a revert.
Yeah.
It's not the same. Yeah. That's local snapshot, I think. Yeah.
So my action item, I think, is to provide links to the KEP and to the PR for the KEP in the agenda doc, which I will do. And I just wanted to mention that this is a weekly meeting, but like we've covered most of the topics we need to cover. So like, unless people have new agenda items for next week, Well, I'll leave the meeting on the calendar for next week, but like, unless there's new things to discuss, we'll probably end up just calling that meeting at the beginning, and we won't end up holding it if there's nothing on the agenda until I have more progress to report or new designs to review, because I have all the feedback that I require, and I want to, I'm happy to like answer questions and stuff or have discussions in these meetings, but we've had all the discussions that I need to have. So the rest of this is for your
you would
benefit.
consider like changing this to bi-weekly if you think you have to spend more time on.
Yeah. I mean, I would be okay with reducing the frequency.
Yeah.
The challenge is like with the holidays coming up, like which weeks do you have on and which weeks do you have off?
Yeah, that's true. Yeah. So
it might be easier just to like leave the meeting on the calendar but cancel it whenever there's nothing to talk about.
Yeah.
Yeah, I think so.
Okay.
Ben, I'll follow up with you offline.
Okay, that works for me.
Thank you. I've got to drop.
Thank you, guys.
Thank you. Bye.